Hello, this is Group 12, and these are our members. This is the outline of today's presentation. We will introduce, understand, and discover in the first part, including our topic and talking about some machine learning relevant problems. In the second part, we would like to introduce methods we have thought, including the structure of model, problem we may make, and so on. And then last, we will talk about the organization of our group. So first, our topic. We want to do the music generation. We want to let AI be able to learn from a dataset and then create a new composition. For example, the music genre of dataset we provided is classical music. Then the computer has to produce a piece of melody belong to classical after reading the music which is provided by user. That is, AI has to finish the melody based on what kind of music genre it had changed. So the next problem is how to let computer realize music. As we know, music is emotional, however, the computer is irrational. The music sometimes can be touching, but the computer only knows about numbers. I mean, they can only read 0, 1, true, false, and something like that. Therefore, how to make computer read music is a problem. After all, computer has to realize music before being able to create them. And about processing the music on computer, we come up with two ideas. First one is sampling in time domain. We transform the pitch to numbers and sample the melody, for example, 10 times per second. So computer can read a 5 seconds melody from the 50 sample points. And the second one is to do the Fourier transform. That is, we can get a spectrum of a melody as the input of the model, and output a spectrum as well. Then we transform it back to time domain and obtain a piece of melody. However, we all have no experience about these two methods. We know little about it, so we may try both and observe which of these will come to a better result. Next problem is, how does computer think about composing? How does creating music look like from the computer's point of view? More specifically, what will machine do when they are composing? We think that this mission may be divided into two parts during training. First is to find something common between the same music genre, like tempo, melody, chorus, and so on. For example, rap may have a faster tempo and lyrics may be gentler. So the machine has to find out where is the common points between these songs and while going through the music in datasets. Okay, this is the first job we think the machine has to do. And the second one is that after finding out these common points, machine has to create music based on these points. Therefore, how to find and how to create are points when we design the structure of model. We have to consider what structure of model will make it easier to find out important features of a music genre, and then using these features to create new stuff. After browsing some materials on internet, we would like to introduce RNN since it may be an important part in our model. RNN is called Recurrent Neural Network, which is little different from a simple neural network. In a simple neural network, the input of a neuron comes from output of a neuron in last stage. However, RNN also uses the output from last time the neuron has produced. That is, there will be a memory to store the value which is output from a neuron. For example, you can see this picture. Neuron not only passes the output to Y but also store it into a cell. So every time the network goes forward, it seems like input value from current time and output value from last time are both the input to a neuron. And why do we want to use RNN? It's because when human doing composing, he will also consider what he has created. The inspiration may come from previous melody, and so does the machine. This job, composing, cannot be divided just like a one thing, and one thing, which are all independent. Instead, whole music is created are very correlated with each other. Therefore, when creating a new melody, letting machine read the past it had produced will give a better result. Next, I will like to make a brief introduction to LSTM, which is called long short-term memory. Just like the picture showing, there is a memory X just the same as the RNN. However, unlike a normal RNN, there are 4 inputs in Neuron. There are input value, input gate, forget gate, and then output gate. Input gate controls whether the memory will accept the input value and then update value stored in memory. Forget gate controls whether the memory is going to be refreshed, and the output gate controls whether the neuron will output the value stored in the memory. Therefore, the memory will not just simply output the value is stored and update. It can decide whether to store, whether to forget, and whether to output. And this action, of course, will be trained during the model training. After and since there isn't enough time, I just take a brief introduction and we'll stop here. So next page I want to talk about is the methods we come up with. We consider 2 methods. The first one is VAE and the second one is GAN.
Hey, hello guys. I'm going to introduce VAE, which is the model that we may try in our final project. And in this part, I'm not going to explain the mathematical details because it's just a brief idea of our final project. Okay, I'll divide it into 3 parts. First, I'll explain what is AE and what is VAE. Then I'll talk about why we choose VAE. The third one would be the difficulties that we may encounter when we're implementing this model. First, AE stands for autoencoder, which is a neural network that tries to make the output to be the same as input. We can see in the picture, the input layer and output layer, they have the same dimension, and the encoder encodes the input to be a smaller dimension data. Then the output, the decoder, decodes the smaller dimension data to the output layer. Okay, that's the brief concept of AE. And VAE stands for Variational Autoencoder. We can see the difference between them is just in the encoder. There are 3 vectors, mean and standard deviation. They are generated from the input layer, and then we also generate a normally distributed error E. Then do some computations to the 3 vectors to generate our code. Okay, and this picture is reproduced from NTU's professor Hongyi Li, Li Hongyi 教授, from his machine learning lecture. And if you're interested in his machine learning class or VAE, you can learn more from his YouTube channel. Okay, let's go back to our VAE model. We know that there in the encoder there are 3 vectors, and the code is just simply generated by taking the exponential of the standard deviation, then multiply by the normally distributed error, and add by the mean. That's our code. So why do we choose VAE? In concepts, we can just choose the music style we want, given that we know which music style lies in some range of mean and standard deviation. So, so we can choose just choose the music style if we fix the mean and standard deviation. So in our final project, maybe given a short piece of melody and the style of music, then we can generate a beautiful and maybe 30-second long melody. Yeah. So, what are the difficulties? First, is the VAE model creative enough? I mean, VAE just tries to make output to be the same as input. So, yeah, all of the outputs are resulted from what it has learned. It's not really creating new things. I think this problem would be fine since that uh, what we aim to do is to generate a longer period of melody with a short piece of input. We don't care if it is from the music library. Yeah, so it should be fine. Then the second problem is that uh, how do we know the mean and standard deviation? What's the range that a music style lies in? We don't know, and we are not sure that if the range is continuous. Also, the mean and standard deviation, they're not the input data when we are training. So how do we select them? How do we fix them if we were using it as some input information? We're not sure. Or maybe we can just train one model that converts one music style to another music style. That's for one model, and we can train a lot of models, so we can convert several music style to several music styles, maybe. And the third problem is that how do we pre-process the MIDI data? We know that there are so many notes and chords, so many combinations. So we have to define the range of input and output to fix the dimension. Yeah. Okay, we'll figure out how to solve the problems if we're really going to use this model. Okay, that's the concept for VAE.
Okay, hello everyone, I'm Ethan, and the other model we may use is GAN, which is stand for Generative Adversarial Networks. First, I will introduce the basic idea of GAN, and second is the input and output format of our model. Next, I'll talk about some possible GAN model we may use, including direct transformation, which is a type of conditional GAN model, and the cycle GAN, which is the extended version of direct transformation. Finally, I will talk about the difficulties of GAN. So let's start. The basic idea of GAN is there are two parts, the generator and the discriminator. And the function of generator is to generate example based on the input vector. Usually, the output is an image. And the function of discriminator is try to judge if the input is real or fake. If the input is more like a real object, the discriminator will output a scalar close to 1. Otherwise, it will output a scalar close to 0. So the scalar is the possibility to be real. And again, it's a combination of the two parts. And when training, at first we will initialize the parameter in generator and discriminator with random distribution. Then the first step is to fix the generator and try to classify example as either real or generated one. Then update the discriminator. And the second step is to fix the discriminator and let the generator try to output examples that make the scalar higher, which makes the output example is close to the real one. Then repeat the step 1 and step 2 until the discriminator cannot distinguish the generated example to a real one. And that is a basic algorithm of GAN. And because I found that GAN usually used to generate image with CNN in its network, so I think maybe we can use the image of MIDI file as input and output format. And also, image of MIDI is good to visualize our target result, our training results. And remind that our project is not only to generate music with the same melody, but also transfer the style, like from classical to jazz. So we have to modify our model to the direct transformation structure, like this one. And now the input is an image, and the purpose of the generator is to transfer the music style from domain A to domain B. And the training is similar to the simple GAN. Also need to update the generator and the discriminator repeatedly. However, sometimes it may not work because it doesn't ensure that the output of generator, this one, is based on the input. That is, maybe the generator always output the same image to cheat the discriminator no matter what the input is. So a solution is cycle GAN. Cycle GAN changes both generator from A to B and the generator from B to A. And during training, it keeps ensuring that the input X and the X, which transfer to domain B and then transfer back to domain A, is as same as possible. So this indirectly makes the output we want to be well based on the input. Also, there are many papers which extends cycle GAN model like the following, like this one and this one. And they all say that they have some useful profit. And maybe later when we have some trouble on training, we can take this structure as reference. And the final is the difficulty of GAN. And compared to VAE, I think the GAN is harder to train, including the following reason. First is the model parameter may oscillate and cannot converge. And the second is that a too-well training of discriminator may cause generator learning nothing. And high sensitive to the high sensitive to the hyperparameter selection. Also, I'm not sure whether the feature of different music can be detected by GAN. So that's my part for GAN model.
Hello everyone, I'm Paul. I'm the last speaker of our team. I will briefly summarize our presentation and put into detail about our work division. To sum up our presentation, our goal for this project is to generate a melody that is similar with our input music and try to make it sound harmonic without noticing the melody is actually created by a model. For our work division, we still need to know further details about these two approaches. So we managed that for the first week, 2 of us do research for more information about VAE approach, and the other 2 members do the same thing with GAN approach. We would discuss both approaches and decide which approach we would try first. After that, we would come up with a structure as specific as possible so that we could make a clear work division. We would see the progress and further decide whether we would have to work on another approach or not. Overall, the actual work division still needs to be decided after the whole structure becomes clear. It is the end of our presentation. Thanks for listening.